Hello, and welcome to Unit 9, Serial Correlation. This chapter is going to be different from the previous chapters we have covered so far, and the difference is going to be in the kind of data we're going to be dealing with. Most of the data that we have looked at is so-called cross-section data, where the bulk of the data is collected at a specific point in time. That is, all the variables are contemporaneously correlated. They're related to each other at the same time. What we're going to be looking at in serial correlation data is data that is temporally related. There's going to exist some kind of feedback going from the past to the present. An example of that, for instance, is a business cycle. We know that part of the GDP has to do with what's happening to the economy right now. But we also know that part of what's happening to the GDP is the result of the momentum of previous actions in the economy from the past. That means that the kind of data is not only different, but also the kind of models that we're going to encounter, and also the kind of problems that we're going to be dealing with. So for this kind of chapter, we're going to be looking at the difference between pure and impure serial correlation. Pure serial correlation has everything to do with temporal dynamics in our data. Impure correlation has to do with us making a mistake about what kind of functional form we're going to choose for a model. That is, if we make a mistake, even with cross-section data, in the kind of function that the variables are related, a problem of serial correlation might pop up even when it doesn't actually exist. We're going to be looking at the consequences of serial correlation, just like we did for multicollinearity. We're going to be looking at the detection of serial correlation. Again, we're not going to be able to go into great detail about sophisticated tests for detecting serial correlation, but the kind of tests that we're going to use are going to give us a gist of the kind of tools that are available to us for detecting serial correlation. One of the most important being the Durbin-Watson test. So we're going to spend a great amount of time looking at the Durbin-Watson test. And of course, we're going to be looking at remedies of serial correlation. How do we actually fix this problem of temporal dynamics not being captured by our model?